Great. And this is my first time presenting here. I'm really humbled, frankly, to be a part of this excellent faculty. This has really been a phenomenal day so far, so I suppose hats off to you, Joe. You have incredibly smart and intelligent colleagues. Either that or Joe, you're in the mafia and everybody's presenting under duress.
Either way.
Basha Leone over here. And Dr. Perkins is modest and humble, and she's really led the effort with the CDC and has been the first author on a number of these publications and really has a handle on this issue. So it's great to hear your experience, Dr. Perkins, especially from the epidemiological side, something I know nothing about, although I'm learning more than I ever wanted to know in my engineering career about the topic. Okay, you can see my slides, great. Okay, I'm here to offer ECRI Institute's perspective, and the first question you may have is, who the heck is ECRI Institute? Well, so I'll give you a little bit of overview of who we are, what we do, and that can shed some light on our perspective. Basically, we're a nonprofit research institute, been around for about 50 years, and we started, our founder was a neurosurgeon fellow, and he really got a fire lit behind him after witnessing a defibrillator that did not work on a pediatric patient, and not just because it was an unshockable rhythm, that kind of thing, but it was a defective device at the time. And there was no real regulatory oversight on medical devices in 1967, or whenever that was, and so because the FDA took that on in 1972. So at the time, really, there was a need for a third-party independent reviewer or oversight institution, and that's what Dr. Noble did. So we still do that. We do comparative studies on medical devices. We publish that to our members, our hospital members. And it's important to know that we have a strict conflict of interest, I suppose you could say, in that we do not accept any funding, any research or consulting funding from manufacturers. So we do these evaluations independently and get supported through our subscription services. So I thought that was important to tell you up front. I have no disclosures for this talk. Okay, moving on. Oh. Okay, so I'm our director of accident investigation. So I go into hospitals when there's been an adverse event, an injury or a death or a close call with a patient involving a medical device or a complex process associated with a medical device, including bypass. And so we've done a number of bypass investigations. We've done some heater-cooler investigations, contamination cases, and we've also done a number of other contamination cases involving the high-profile endoscope, duodenoscope superbug issues that we've all read about in the news lately. We might have a little delay from the distance here. Okay, so let's talk about the heater-cooler a little bit. Here's the marketplace, and Sorin 3T, that's the dominating component. That's 60% of market share approximately. We also have Cincinnati Sub-Zero, McKay units, CardioQuip, and Terumos are still out there. And the Terumo, just a little tidbit, the consent decree from manufacturing from Terumo has been lifted as of middle of last year. So who knows, we may start seeing Terumo products on the market in the coming years, maybe after all this settles down with the heater cooler. We'll see. But am I telling you next slide? I'm sorry. Okay. So everybody knows what a heater cooler is, but I thought I'd give you just a little bit of the regulatory background. It is a Class 2 device. It's cleared as a cardiopulmonary bypass temperature controller or a thermoregulating system. And what we're really involved in is a dynamic and exciting post-market surveillance era of this device. So the device is released to the market, and there's post-market surveillance, and that's what we're in right now. So we have a problem. We have problem reporting. We have these reports of contamination coming back to the FDA, to the CDC, state departments, and we've identified a hazard. Okay, we have identified a risk or a vector of transmission from an MTM. So we have a specific hazard now, and now we're in the process of the recalls, the engineering solutions that are out there. Dr. Perkins mentioned the retrofit for the aerosolization canister. Those types of things, that's what we're really excited about, at least I am from an engineering perspective. So in that, because it's a forcing function, technically, it takes the risk out of the user's hands, right? So and I'll get into residual risk in a little bit, but it really takes the risk out of the user's hands when you have an engineering solution. So that's what we really want. And in the meantime, we're trying to mitigate that risk as best we can ourselves as users, not me, but the perfusionist community as users of the device. Okay, and then we get the modifications and the instructions for use to account for some of that risk that's still left over, despite all the engineering solutions. So that's where the modifications and IFU come into play. All right, so this is a little bit of overlap with Dr. Perkins' talk, but that's okay. If you're like me, you need to hear something about 10 or 15 times before it sinks in a little bit. So I just want to quickly go over this. We have, over the last, this is shortly following, in 2015, shortly following the Pennsylvania outbreak, the Swiss outbreak, and a German, I believe, outbreak during that time. Dr. Perkins mentioned the Greenville, South Carolina event, and so there was a lot of heightened awareness at the end of 2014, early 2015 timeframe, and that's when field notices started coming out. There was a recall in the instructions for use in response to the corrective and preventative action by Sorin Livanova. And then in December of 2015, that's when it really hit the fan, so to speak, and that's the warning letter that was issued from the FDA to Livanova. And most big manufacturers have unfortunately received such a letter, but so Sorin receives this letter, and the bottom line is, and you see kind of a brief summary on the right side, is that this did follow a prior letter in 2011, but it followed the FDA inspection of Munich and Colorado manufacturing facilities, and really it came down to no verification or validation of the new cleaning policies in the IFU, a number of other things, but that's what they really emphasized in that. So there was a warning letter, and at that point there was a limitation of the import of the Sorin 3T to the US. So that's a big deal. Sorin responded by a letter to the customers. Actually, next slide, I think. And then we move on, and we have this great guidance from the CDC, and we have guidance from the FDA. And now we're at a point in October of 2016 where that's essentially our most up-to-date guidance. So if we've all seen that, and I'll summarize some of the recommendations on that at the end of the talk, then we're up to speed on what CDC and FDA are recommending. Okay, that jumped a little bit, I think. Sorry, we're computing. All right, so I wanted to dig in a little bit on the June 2016 FDA communication, because that's the line in the sand. That September 2014 date we see is the reason for that is because of testing on the manufacturing plant line that identified the M. chimera, and then identifying it later as a point source for the infections in Europe. So we see that September 2014 date really is the line in the sand, and this is why. So we have devices that are manufactured prior to September 2014 in the marketplace that are theoretically at a higher risk of contamination and aerosolization to a patient. Okay, so Livanova made changes on the manufacturing plant with disinfection on the line, on the product line, and did some follow-up testing and found no M. chimera. So we think that at that point, they found the solution. And there was also reference to the European studies in that FDA communication. So that's important because that was really, like I said, the line in the sand there. Now, the executive committee meeting, as Dr. Perkins brought up, was really another pivotal time. That's when the FDA brought in manufacturers and outside parties to go over all this and discuss this in great detail. And the FDA has a MedWatch, they call it a reporting program, if you're all aware, where medical device reports are submitted, and they reviewed over a period of time how many were associated with infection, and then did a breakdown by manufacturer, et cetera, and found that there's approximately 180 FDA MDRs at the time. This was mid last year, and you can see the breakdown by manufacturer. And admittedly, with the marketplace, the Sorin unit has the market share. But we do have reports associated with contamination of devices, not patient infection, with the other manufacturers as well. So that's important to know. Okay. All right, so is this really a big deal? Now, I've learned from you all in private discussions, but I just kind of want to do an old-fashioned poll. I don't have the technology with the A and the B right now, but just a show of hands, because I'm very curious, who has had a Sorin 3T in your facility or in your perfusion group over the last 3 years? Okay, that's a large number of people. Okay, keep your hands up, please. Okay, now keep your hands up if you still have the Sorin 3T. All right, that's interesting. So we do have hands up. We have about, I'd say about 2/3 of the hands dropped there. Okay, so now let's ask it in reverse. If you've had another device, another manufacturer, a CardioQuip or a Cincinnati or McKay, have you switched to Sorin in the last, say, 2 years? Are there any hands? No hands. So that suggests that the marketplace thinks it's a very big deal, and it is a big deal. I mean, it's a big deal because we have identified a vector for transmission of potentially deadly bacteria for immunocompromised patients, et cetera. So we know, is that me, 0? No. No, just ignore it. Okay. It's like, wow, 0. So it is a big deal because we've identified this vector, and it's part of our greater risk of surgical site infection, of patient infection in cardiac surgery, but we know it exists now, so let's squash it. Let's attack it and squash it. And I'm not suggesting we have to all switch to another manufacturer, though. I want that to be clear. I mean, it's our perspective that this risk exists with all manufacturers that have water in it. Some may be more at risk of aerosolization than others, but we have to weigh that risk with usability and functionality and everything. We have to put it all together in the same package, and then when we're going to assess whether or not we're going to continue to use or to purchase a heater cooler device. Okay, so I hope that's clear. We could talk about that more later. And we also see it at ECRI Institute with our members calling in, and one of the services we provide is a customized quote analysis. So people can send us quotes for devices that they've received from manufacturers, and we'll analyze that and put it in perspective and tell you if it's a good deal or not. And we've seen a dramatic uptick, as you can see from this plot, from 2015 to 2016. Not a surprise. People are calling, very concerned. Should we go to a new product? Here's what the quote says, et cetera. And if you break that down a little further, next slide, please. And this is the breakdown for the manufacturers that are sending in those quotes. So the hospitals are sending them to us, and you can see the breakdown. And what's dramatic is, look at the 2016 bar. So the blue, orange, yellow, and green, I think, goes from 13, 14, 15, 16. You see the dramatic drop for Sorin quotes, and you see the dramatic uptick in the CardioQuip and the Cincinnati Sub-Zeros. So it's not a surprise. It just kind of puts it all in perspective that we're getting a lot of inquiries on which models to go with and who to use. So from a market share standpoint, it's a big deal. From a patient safety perspective, which is what our organization is really interested in, it's also a big deal. Every year we put out our top 10 hazards, technology-related hazards, and this year it was number 5. So there are others, but just to show you, number 2 was the cleaning of complex instruments. That's the endoscopes, complex surgical instruments, arthroscopy drills and things. So that's where we think it is as far as from a patient safety perspective, obviously very important as well. Now, risk. It all comes down to risk. I mean, we're getting into incidents and risk, and there's a lot of different ways, a lot of different discussions that can be had when we bring up the word risk. And we have things like hazards. We have the risk itself. We have a risk control, which is built into a manufacturing process. That's you think failure mode effects analysis. That's how we control our risk. We have residual risk that when you're done with all that, there's still a chunk that's a residual risk that you have to, that maybe can't solve. And so you identify that, you know it's a risk, you put it in as a warning or precaution and instructions for use and train accordingly. Now, there's also new risk and unanticipated risk. All right, let's consider this NTM aerosolization as an unanticipated risk. Not that the devices can be contaminated, waterborne bacteria, but the unanticipated part is the aerosolization vector to the patient. So that's the realm we're in there. New risk, I bring that up here because when we switch, for example, to another manufacturer, if we want to do that, there's going to be new risk brought in. It might not be aerosolization of NTM, or it may be, we don't know, but it might be something else, some controllability of the temperature or something. If you don't have the incremental level that you want, for example, or ease of use, size, if you like ice or don't like ice. There's more usability factors that can be brought in that you don't anticipate unless you really vet it through. Your users, if this group really vets it through the perfusion practices to really be comfortable with bringing in another unit. So just know that bringing in another unit does bring in new risk, new potential unanticipated risk, and that's something that we try to drive home. Okay. And this is all controlled, and this is all regulated. I mean, manufacturers have a burden of to follow the good manufacturing practices. This is now built into the Code of Federal Regulations to have a quality management system to deal with these potential risks. Okay. So let me back up one. All right. Now, Dr. Perkins has mentioned that, or the CDC has mentioned that so we get to the incidence now. We talk about risk. We know this. We agree the severity is high, right? I mean, if a patient does get contaminated and leads to an infection, I think it's not too hard to argue that the severity side of that equation is high. Now, the incidence is debatable. I mean, we have kind of a limited data set, really, and we try to get as much as we can out of it. And the CDC has estimated that if the facility has a device known to be contaminated, that risk, or let me just make sure I say this correctly, where at least one infection has been identified, okay, the risk of getting an infection is somewhere between 1 in 100 and 1 in 1,000. And when we open up to the panel discussions, Dr. Perkins may be able to elaborate on that a little bit more. But the real hard question is, and that's not an easy one, but the hard question is, what's the risk moving forward? If you don't have an infection in your facility, what's the risk of using these devices? What's the incidence rate of an infection? And what we tried to do is come up with a way to address that. And I put in big bold letters in the parentheses, back of the envelope. I mean, this isn't something that we've published. This is something that is ongoing discussion. And I'm really curious. I'd like for you to challenge us, challenge these numbers, in the panel perhaps, to come up with what we think the real incidence is. I mean, because what we've done here is we assume a certain number of surgeries per year. We know the marketplace. We know about the number of infections in the US right now. And we know that 2/3 of the 3Ts in the marketplace, now this calculation was done about 6 months ago, so bear with me, but about 2/3 of the marketplace at that time were 3Ts manufactured prior to the line in the sand, September 2014. So we have a good understanding of what devices are out there, how many procedures are being done. Now, if we consider the latency period, could be about 4 years to develop an infection, and if we consider about 2 years or so where we've really learned that these infections are going on, then we've got about 6 years of data, I'd say. And so if we make a simple calculation, that shows about a 0.01% incidence rate, okay? And so that's about 1 in 10,000. Now, we can play with that denominator all day long, and we can get different numbers. But roughly 1 in 10,000, or if we say 3 years, if we say this is predominant for about 3 years, then that's about 1 in 5,000, okay? And I think this is okay, and I don't want to call out Dr. Perkins, but we had a sidebar conversation and thinking, yeah, that sounds about right, So, but I'd like to hear about your experiences in that regard, and see if we can get a more accurate number. But let's back up a little bit and see how this plays into the overall SSI and cardiac surgery. Okay, so if the CDC has reported that there's 1 in 25 patients will acquire at least one hospital-acquired infection. 30% of these are surgical site. And then if you break that down to cardiac, There's something about 1 to 5%. That number can be argued. Result in a surgical site infection. If we use that 250,000 number, we get about 1 in 25 cases. Okay, so think about that for a minute. The previous slide we had 1 in 5,000, let's say 1 in 10,000 of infections related to the bypass heater cooler, and we have 1 in 25 on cardiac surgery. So we have 25 patients rolling through. There's an infection, it's not the heater cooler. There's another 25, there's an infection, not the heater cooler. On and on and on and on, and you get one that's the heater cooler. But what I'm getting at is, despite what that number is, if it's 1 in 1,000, 1 in 5,000, 10,000, it's a subset of the overall picture of cardiac SSI, cardiac infection, but it's still important. I mean, we've identified a definite vector of transmission, so we need to squash it. Okay. Next slide, please. Okay, the CDC Alert. Dr. Perkins already reviewed this, so I won't spend any time talking about this. But this is the October 2016. This is the up-to-date information, so I recommend taking a look. And so the FDA recommendations, and basically they go like this. If you have a device manufactured, if you have a device that's known to be contaminated, remove it. I mean, that's essentially recommendation number 1. If it's manufactured before 2014, strongly consider transitioning away from these devices, and then use it for emergent cases. There's a form you could fill out, a certificate of medical necessity if you want to go that route. FDA is not recommending microbiological culturing, and that's fraught with error. The technique itself is difficult. So, and that may be something that Dr. Perkins can address as well. I'm putting you on the spot, sorry, Kieran. So anyways, it's interesting though, because that's a debatable thing in the field too, about should we be sampling these and how often and how do we do it and what do we sample. Okay. All right, next slide, please. Okay, I already talked about that. Next slide, please. So the vendor guidance, and this is from the Livanova incidences, but basically, the one thing, I mean, you have a big exhaust fan on the back of the 3T, and if we point it to the exhaust of the OR, that theoretically will reduce or mitigate the aerosolization. Because if we think about that mechanism, I mean, actually I should bring up one important point. The bacteria, the NTM, they're not transmitting necessarily through that fan. So we've had questions like, should we throw a HEPA filter on the fan? Or bacterial filter on that fan to catch this transmission, and it's not going to get it all. I mean, theoretically, it could get some, but if you have this hydrophobic NTM that's catching the air bubbles, as the air bubbles are collecting on the surface and then finding a way through the chassis of the 3T or heater cooler. I don't want to pick on the 3T, but if it escapes through the chassis, it can catch the wave of that exhaust fan, the turbulence in the air, but it's not necessarily going through the fan itself. So that's an important distinction, and I think that it makes a lot of sense. You want to point that exhaust fan toward the exhaust of the room. Okay. So, all right, next slide, please. So this is on our top 10 hazards, like I said, pointing the fan against the room. Obviously, we can think about it like this. I mean, we want to do it sort of 3-phase. One, we don't want the NTM to get into the heater cooler in the first place. We can mitigate that by filtering our water supply, by being extra vigilant on how we handle the device during disinfection. Let's assume it does get in. We want to have our policies in place so that the disinfection is being done in accordance to manufacturing recommendations, all the right disinfections, et cetera. And I mean, I think that's, I had a third. Sorry, anyways. I think if we assume that it can get into the device, we have to have other processes built in, such as locating a proper placement of the heater cooler in the OR. If we have that risk mitigation strategy, which we do now because we're getting educated on this by FDA and CDC, then I think these numbers will drop. Okay. Next slide, please. Okay, I put this in a schematic form because we actually had a case like this where we went to a hospital and it was directed in line with the instrument tray to the OR exhaust, the plenum. And obviously that's a problem. And this is interesting, the Canadian study that Dr. Perkins brought up with the minimally invasive example. I mean, anything on a tray has a potential of picking up some of this bacteria that's aerosolized. So we have to be especially careful of where this is in our room. Okay, so we saw this in a hospital, and we helped them figure out this, relocating and reconfiguring the OR to mitigate this. Same hospital also asked, and this goes on to next couple slides, that's okay. The same hospital asked, should we modify the 3T, or should we modify the heater cooler and build a cart around it, or build something around it to catch the bacteria and eliminate it from the OR, or put up a sheet or something. And that's a difficult one. I mean, we generally suggest to not modify in any way, essentially, the unit itself. I think the Iowa example of relocating the heater cooler to an adjacent room or the pump room and have tubing run through to the OR is a good idea. I mean, I think that as long as we meet the restriction of tubing length, we don't want to have tubing that's too long, but if we do have it in another room, I think that's a good idea. But modifying the unit that's in the OR, I don't think that necessarily is a great idea, because it does bring in new risk. I mean, if you have a containment, if you have a structure around the device, for example, we think about heat loss and the ability for the device to work, and in the end, we want the device to work. I mean, the temperature control, lack of temperature control is far riskier than aerosolization of an NTM. So we discourage device modification, and we encourage more along the lines of the cleaning practices and the processes that we can do to mitigate this. All right, do I have any other slides? I think that's it. So you could advance to the end, please. Okay, so I mean, I think just kind of a concluding statement, and then we'll move on to questions, is that the risk has always been there. And we don't necessarily know what percentage of infections over time have been associated with this until recently, where there was testing done at the manufacturing plant and a point source was identified. I mean, then we start to say, okay, now it's starting to make some sense. It's coming from the heater cooler units. But essentially the risk is always there. It's a water containing device. So Dr. Perkins mentioned a lot of other water sources that can bring in this NTM. So the risk is always there. It's a heightened awareness now. And I think we will start to see some engineering solutions. We will see some modifications that should help. And I think just the awareness itself should help in some of our policies and processes. That's all I have.